Oh, nice.
I didn't have it, so.
Perfect. Even better. No 30 minutes of like silent. Ah. Hi, everyone. We're going to get started. So if everyone can take their seat if you want to. I'm not your boss. Yeah. Welcome to our November Chicago Ruby Meetup. As a reminder, we aim to meet every first Wednesday of the month. I want to thank Cisco and the folks at Cisco, Kevin and his team, for letting us use their space and for being such a gracious host. With that, I'm going to hand this off to Kevin for a bit to talk a little bit more about Cisco.
Thank you.
Yeah, you can just give it back to me.
Hi, everyone. My name is Kevin Hurley. I'm an engineering leader here at Cisco. I used to say Cisco Meraki, but we're kind of winding down Meraki as a separate brand. So we really have to say Cisco, which means since we're at Cisco, we're going to be using WebEx tonight and all of the other things involving Cisco and the Cisco brand. So first of all, thank you all for coming tonight. Really, really glad to see everyone here, and hopefully you're enjoying our hospitality and enjoying the office. If you have any questions about where to find things, or if you have any questions about Cisco or what we do, happy to answer that for you. But believe it or not, Cisco does use Ruby. In fact, a lot of Ruby. We have a big Ruby monorepo that has over 3 million lines of code. As one of my colleagues is fond of saying, it is the biggest Ruby shop you've probably never heard of. Definitely on par with like the GitHubs and the Shopifys. So I'd love to talk to you more about that. I'd love to talk to you about Ruby. If you want to stick around after, if you want to hear about Cisco, Meraki, or anything else that we have working on, I'd love to have a conversation with you about that. So again, thank you all for being here. Thank you all for coming, and enjoy the meetup. Thanks.
Cool. Thanks, Kevin. Yeah, so before we get started, next slide. Yeah, I'm going to go through some quick housekeeping and announcements. First off, join us for our future events. We will post our events on meetup.com, as well as these community Slack channels, hashtag Meetup USA Midwest, Community Social Random, within the Ruby Central community Slack, as well as the Ruby channel on Chicago Tech Slack. Reach out to me if you need an invite to any of these Slack channels. Next. Interested in hosting? Chicago Ruby is on the lookout for organizations willing to host our monthly meetings. If interested, reach out to Dan or Anton, Dan, or myself, and we can give you more info. Boop. Okay. Interested in speaking? Oh, what's happening? Okay. Yeah, that's fair. I see. Can I? Okay. Wait, I don't know. Okay. Yeah. Yeah. Where was I? Oh yeah, interested in speaking? We would love to hear from you. Feel free to reach out to me, Anton, or Dan for more information. If you're interested in speaking but unsure what to talk about, or if you're interested in hearing a specific topic, we've compiled a list of potential ideas that members of the community are interested in learning more about. Feel free to add your ideas here. There's a QR code over there to a Google spreadsheet. This Google spreadsheet is open for comments only for moderation purposes, and admins like myself will add ideas from comments onto that list. I'm gonna keep that for like 2 more seconds. Boop. Wait, I don't know. Your clicker isn't working. Okay. Oh, if you're interested in Chicago Ruby, either by hosting a different type of event, like a hack night, code and coffee, collaboration with other groups, or through a sponsorship, we are so down. Let us support you, support us. Reach out to me for more info. Doop. Okay. Oh yeah, some other announcements. These companies have reached out to us to share the word that they are hiring. Prevail.ai has open positions for a mid-level as well as a senior full stack developer. Reach out to Dan, hand waving over there, for more info. He's attending today. I wrote that on my notes. Chime also has an open position for a senior level software engineer. Reach out to Noel Rappin for more info. He's available on Ruby Central Slack, but I can also get you guys connected. And I'll leave the mic open for a minute or two for anyone else who has announcements about open positions before I move on to more exciting announcements. Sounds good. All right. Last off, join us next month. We will be hosting a Chicago Hack Night event the first Wednesday of the month, December 3rd, from 6 p.m. to 8:30 at DPI, Discover Partners Institute. We will have one speaker, Jeff Cohen, over here. Yeah. Event is titled Twas the Hack Night Before Christmas. Very exciting. And then with that, I'm going to hand off this mic to our first speaker, Andy Andrea. Here's this.
I just hold this, or
You can also clip it on. I just chose not to. And then Kevin.
Perfect. Yes, this is indeed me. Does this work? Oh, hey, it does. Amazing. I forgot my clicker, and I also haven't changed the batteries in my clicker in 3 years, so even if I hadn't forgotten it. Yeah, so for those of you who actually read the meetup notes, you will not recognize this title. I think I originally said something along the lines of reusable JSON schemas, and I was thinking to myself, I don't know that that really tells the whole story. So instead I chose a title that tells no story whatsoever. My name is Andy Andrea. I live in Durham, North Carolina, but if anyone from Chicago has driven north and seen signs for the Ren Fair or the Brat Stop, that is my hometown of Bristol, Wisconsin. So I have some ties in the region. I don't want to say area. I've been working with Rails since 2014, so a little over a decade. And today I'm going to talk about JSON schemas. And well, not exclusively JSON schemas, but we're going to start off with a schema that everyone will probably think is fairly familiar, and we're going to have it go on a little journey through an entire Rails application in some areas that you might not be used to seeing a schema. And so naturally, the first stop as Rails devs is the database. And as a quick aside, there was a great talk in Portland a couple years ago by Aji Slater called the TDD Treasure Map. And in that talk, Aji put like a lot of effort into making some really nice slides and some really nice graphics of like all this treasure map motif. So I thought, well, maybe I will, be inspired by that and try to make some nice little things to go along with my travel motif. But unfortunately, you do not have Aji. You have me tonight, and I procrastinated. So I just typed in random things into Google Maps until something showed up. And so our first stop is the Postgres Conference Nepal, which is the first thing that pops up when you type in Postgres to Google Maps. And what a better place to start than somewhere that exclusively has 5-star reviews, meaning 1 review in total by local guide Mario. And so for this stop, our database stop, we have the schema RB. We're probably pretty used to looking at this file as Rails devs. Looks something like this. One thing worth noting is that the copy paste that I did of my syntax highlighter was originally looking wrong and now it looks fine. So never mind, forget I said anything. But here we've got a simple little table, a students table. I've been working in ed tech for the last couple of years, so I thought this would be a little familiar. We've got some string columns related to the name of the student, some Boolean. We've got that little array, text, teacher notes, our timestamps, fairly normal things. We have names, we have some null constraints, we have types, very, very similar to anything else that we would think of when we think of a schema. So there's not much to talk about here. Allows the database to work, tells us how the database is structured, and enables a lot of Rails magic if you're using Active Record. So the next stop, going to the controller, where apparently the closest thing with controller in the name was controller road to me when I wrote this. Also, you'll see that we're not starting at Postgres conf Nepal because there's no address for Postgres conf Nepal in Google Maps. If only there was some kind of technology out there that could tell you where something is and how to navigate from it, but apparently that's too much. So instead I found this place called PostgreSQL in Brussels. So that's where we're starting. So why will schemas be relevant to us in a controller? Well, you might be familiar with JSON schema. A fairly common use case for this is you have some API that takes in some params, and you can then validate that those params look like they should. So things that can't be null aren't null, things that are a string are, or you expect to be a string are a string. And if you have this validation in place early on in your controller layer, that means that you don't have to do any defensive programming in your API handling, because you don't have to worry about nulls. You don't have to worry about casting to a string, because you know if the validation has succeeded, then it's valid. And meanwhile, the validator also will probably give you some really nice error messages if you want to expose those to the consumers of your API. But what I think is a little bit more interesting is if we flip this idea on its head a little bit, and instead of validating our incoming requests, what if we validate our outgoing responses? So this might feel a little bit weird because it implies some lack of trust in the code that we have written ourselves. And if we can't trust the code that we're writing, what are we even doing as devs? And so a quick little story on this topic. I've been working on an app that's about 10 years old or so. And for those 10 years, we've had basically one audience, which are educators. We do have user roles in there like administrators, teachers, guidance counselors, and the like. But everyone that has worked on this app for the past decade has been able to work with the assumption that the code they are writing, the way that they're structuring the app, is for use by educators. And that assumption held true for about a decade until I joined the company and I started working on a feature to make some data available for family members. And we had kind of all the standard deadlines and worries about maintainability and getting things done on time. But we also had to consider the security aspect of everyone that's ever worked on this application is been able to make this assumption that the data that goes into our application is being read out in our UIs and our APIs by a particular set of people. And now that has changed. And so we were a little bit worried that all of these other teams that were still working on this same shared code wouldn't know about this feature, or maybe they would forget about it and they would accidentally make some change to shared code that would expose something that we didn't want exposed to family members. We think back to our schema with that teacher notes. If suddenly you've been taking notes in this application for 10 years and suddenly you think, oh no, what if this is going to be visible to family members? You have to go back through 10 years of notes and think, okay, is this thing that I wrote possibly like easy to misunderstand or could be taken the wrong way? And then you have to go and think through all this stuff. And we didn't want to put our users through this. So instead, for the couple of endpoints that powered this family-facing feature, we decided, why don't we use schema validation to say that we have some kind of check in place in our tests, in our local environment, in our QA environment, so that these endpoints will actually blow up and tell all of our teams, regardless of whether or not they even know of this feature's existence, something is wrong and they have to look at it and think about whether or not this data should be exposed to this narrow subset of users. And this is pretty easy to make in Rails. So we have something that looks something vaguely like this. where we have a controller. It includes a concern that gives us this validates response schema method. We've got a show endpoint that renders some student JSON. And then we have this schema method that we've got a little schema builder utility class. I'm not going to go into that too much, but then we pass it in this constant that is defined kind of arbitrarily in our student model. And it looks something like this. And it's very similar to the schema that we already have in our schema.rb, except it's now in JSON schema format. So instead of null constraints, we have this required key saying that first name and last name are always required. And we have these series of properties. The ID is an integer, the first name is a string, etc. And we've also taken a few things out, the things that we don't want those family members to see, like those teacher notes. And we've also added this additional properties false to just say we don't want anything that's not explicitly laid out here to be visible. So then looking at that concern that we saw included in our controller, we've just basically defined some around actions that call out to validates response schema bang, an instance level method. And we've also given ourselves the ability to skip this validation if we have some kind of endpoint that we know is not going to return any sensitive data. And then that validates response schema bang method, it yields so that our response body has been populated. We don't care if the response body is blank because there's not going to be any sensitive data in a blank body. And then we use the JSON schemer gem, which is one of a number of JSON schema gems, to validate our schema defined in our model against our response body. And if anything is off, we blow up. And we have set this up so that you can turn it off for particular endpoints. You can pass it in anything that you could pass through a round action. If you want to have it conditional based on your environment, say this only runs in development and test, maybe in staging. We don't want it to actually blow up in prod if we really trust our processes in those lower environments, then you can do that. And you can turn it on just for the endpoints that you want. And just again, this is what it looks like. So it's pretty simple. You just have to pass in or include that concern, call the validates response schema to set up your around action, and then define your schema method that gets read by that validates response schema bang. And you can imagine if we had multiple endpoints, you could have like a case statement around the action param, say it'll be this schema for show, it'll be that schema for index, etc. So that's the schema in the controller. We've seen two ways to use JSON schema validation, one validating your incoming requests for your APIs, and the other validating your outgoing responses. So our next stop is our test suite. I thought this was kind of interesting. There's a place called rswag design on a Chicago drive in Michigan, so I thought that that felt appropriate. So what are we doing in the tests? Where do schemas help us out here? And they help us out by writing request specs with the rswag gem. So if anyone hasn't run into request specs in rswag before, think of them as basically the API version of an end-to-end or a feature test where you are calling out to an API and probably stubbing very little as if it's an end-to-end test. And so here with the rswag gem, we've got a little bit of a different API if we're used to just writing plain old rspec, where we pass it in a path that responds to our endpoint. We say we're calling a get request. It produces JSON. It takes in a particular param, that ID that comes in directly in the URL. And in the happy path, it responds with this particular schema, the schema that we defined in that same model. And you also have to set up the request params let so that it just knows what to pass in when it's calling your endpoint. And then all you need to do is run test, and you should have a passing test. And it does kind of a lot for you in here. It checks that it returns JSON, it checks that it responds to the schema, it checks that it handles this param correctly. It's really nice in quite a little bit of code, certainly a lot less than any feature spec I've written in rswag before. One thing worth noting here is that we have moved from one technology, JSON schema, to another, OpenAPI or Swagger. The two are very similar. They have some differences that I'm not going to get into here. You can Google it fairly easily. I'll say that for the work that I've done, The only issue that I've run into is
One.
Okay, cool. Oh yeah, it's not shared on. Oh, what do I? Share on the web. Yeah. Oh, okay. Yeah. Okay. Okay. All good? All right. How many devs does it take to debug something, right? All right. So yeah, back to our test suites. Basically, the schema in our tests gives us the ability to write quicker, less verbose request specs with the help of rswag. And if anyone knows anything about rswag or Swagger, it's probably not surprising that our next step is documentation, or our next stop. I think this is a hilarious name for a business, the Swaggerty Sausage Company. It's the first thing that popped up when I typed in Swagger. But so why the docs? And well, the answer to that is a schema is essentially a form of documentation already. I mean, Rails uses the schema RB essentially like it would use documentation. It reads it and does a lot of active record magic. And it's always nice to have more documentation that's easy to maintain. And so with the rswag gem, again, the Ruby version of Swagger, we can do a little bit of setup, throw in an initializer as well as a Swagger helper. This stuff is basically straight from the documentation, so you don't need to worry about the specifics too much. Once we've got these two files in place, then instead of just running our request spec that we've already generated in our previous stop, we can instead run the rswag specs swaggerize Rails task, which is one of the most fun words I've ever said. And it looks pretty similar to running RSpec. You can see the one example, 0 failures, finished in X seconds, but it also tells us that it generated this swagger.json doc. And it's got basically everything that we set up in our request spec. It tells us the endpoint, it tells us it's a get, it tells us that it takes in that ID param, and it tells us a little bit about the ID schema itself. And then in the response, it's got basically the JSON version of our Ruby constant that we defined. So our schema has transformed from our original schema.rb format to our Ruby hash to now this JSON. And of course, we can just fire up our server and check out the Swagger docs, and it gives us this nice user-facing documentation that we can make available to anyone who can call our API, whether those are internal users, external users, whoever. And so we have automated documentation generation that's very user-friendly, and it's very, very cheap to maintain. Now, you do need to rerun that rake task if you have your swagger.json in your Git history. What we've done at work is that we just have a build kite step that runs that task and sees, did the file change? If so, the build fails. So just say you have to go run this and commit it before you can pass. Now, the big one. the one that will either make people roll their eyes or get someone excited, AI. And regardless of whether or not you're eye rolling or excited, I'm probably going to disappoint you a little bit on this because I'm not going to go into too much detail. This is going to be a little bit more ideation than true implementation. So why AI? Well, do we really need to ask that question in 2025? Well, what we can use schemas for with AI is, of course, we can pass it as documentation to coding assistants, but we can also use it as a sort of tool registry. So documentation for coding assistants, this is pretty straightforward. If you use Copilot, Cursor, Windsurf, and you have a schema, you can attach it as context when you're chatting with your assistant. If you also have JSON schema validation in place, then that means that not only is your schema describing how things should work, but you're actually describing how things have to work because you've got that enforcement mechanism in there as well, which can give really good extra context for your coding assistants and for yourself. Now, the tool registry side, I think, is a little bit more interesting. So for anyone that's working on anything agentic, where you have an agent that calls out to a tool, basically a tool just being something that an agent can call that does something. And we have the notion of a tool in a lot of different AI architectures, libraries, gems nowadays. In this example, the Ruby LLM gem, if you look at the tool class, we'll see that it has a name, has a description, has parameters, and has the ability to be called. If you look at those parameters, they have a name, a type, description, and whether or not they're required. So it's starting to look very, very similar to the schemas that we've been looking at so far. Switching gears a little bit to langchain.rb, they do things a little bit differently, but when you look at their tool definition.rb, you actually see a bunch of references to schemas directly. And in their parameter builder, you see types, names, whether or not something is required. So again, it's looking very, very similar to what we've been seeing already. So recap, a tool, something that has a name, a description, params, and the ability to be called. And those params themselves have names, types, descriptions, and whether or not they are required. So if we look back at our swagger.json, we can see that this looks pretty much like the definition of a tool that we've already seen. We've got the summary that acts as kind of both a name and a description. We've, of course, got the params. And then we've got how to call the thing. Send a GET request to this endpoint. If you need any more reinforcement, looking at the docs for MCP, the Model Context Protocol, you can see their tools have names, descriptions, input schemas, properties, whether or not those properties are required, the property types, descriptions. Again, very, very similar stuff. And looking back at our Swagger, it's basically the same thing. We've got our properties, whether or not they're required, types. I also found this gem called Ruby LLM Schema. I haven't really looked into this too much, honestly. This little snippet here is just from their README on basically how schemas are useful for LLMs. So it could be something interesting to look into if you are interested. So quick recap, we've got documentation for coding assistants, attach it in your requests to Copilot, to Windsurf, to Cursor, and then that tool registry idea. And so I haven't really talked about the specifics of a tool registry. I think that's probably its own talk for how it relates back to schemas and Swagger documentation. But you can probably fairly easily imagine building up those, say, Ruby LLM tool classes automatically based on the output of your swagger.json. And yeah, of course, the money aspect. So our final stop, the front end, where everyone loves to go, right? So why the front end? Where do schemas matter? Well, with a schema, we can help keep our front end and our back end more in sync. And it lets us spend less time on the front end, which, I mean, we're all at a Ruby meetup and not a JavaScript meetup for a reason, right? So there are actually a number of libraries out there that allow you to generate TypeScript types directly from Swagger. I've played around with this one, OpenAPI TypeScript, but there are a number of others as well. And to get this working, if you think back to our swagger.json, currently all that's in there is things about our endpoints. We've got the paths and what they look like, whether or not it's a get, a post, a put. And so since we're in the TypeScript world, not so much concerned about our paths so much as entities or maybe models, we can hard code in references to our components and their schemas. So going all the way back to our second stop, that family schema constant that we defined in our student model, we can put that into our Swagger helper.rb under components schemas. These are just static things that will be included in the output from when we run that Swaggerize rake task. And then we run the rake task again. We look at the swagger.json. Now we've got the components, schemas, family student. And so it's just, our normal JSON output as we had up above when we were looking at the paths and the input and the output of those API endpoints. But then with this OpenAPI TypeScript library, we can just run it, pass it the swagger.json, give it an output path, and it'll give us all the info about our paths. We might not really find that terribly relevant for our TypeScript types, but then we also get this thing at the bottom, that export interface definitions, family student. And so you can simply, very easily define your student type by doing student equals definitions of family student. And now with one quick command, you've got your front end in sync with your back end, which can be very, very helpful. Now, again, just like the Swaggerize rake task, you do have to keep running that over and over when things change to keep it up to date. But of course, you can add something to your CI or your dev process to make sure that that happens. So that was our final stop. So quickly in summary, we started off with the schema in the database, saw it move to the controller, the tests, the docs, AI, and the front end. And over the course of this journey, we saw it transform from this active record schema into a simple old Ruby hash in a kind of JSON schema-esque fashion, into JSON, and finally into a TypeScript type. Now, I will say there's a lot of other fun stuff out there with both JSON schema and OpenAPI. I included a couple things I thought were interesting. For both of them, they published a bunch of lists of tools online that you can read up on, as well as the spec. Yeah, some really cool, interesting stuff that I'm hoping to play around with in the near future. So all that said, thank you everyone for coming. Thank you to the organizers, to the sponsors, and going back to the beginning, thank you to, of course, our good friend, local guide Mario, for your review of PostgreSConf Nepal. Do we do Q&A or anything? Okay.
Does anyone have questions?
Not, you're happy to find me at the end?
Question.
Yeah.
Yeah, do you have an alternative for rswag for someone that uses Minitest instead of rspec?
I don't. I have very little experience with Minitest personally. Yes, I always forget to do that. The question was alternatives for rswag for people that use Minitest over rspec. And off the top of my head, I do not. The first place I'd probably look is the awesome Ruby list on GitHub. But I don't know that that would have anything.
Yeah, some context is I am using JSON schema, not in the controller, but for testing. I'm a QA manager for my company.
Oh, nice.
And it's awesome. I love it. I set this up like 2 years ago, so I don't really remember the rabbit hole I went down. But I think I wanted to do the same thing you were doing. And I'm like, crap, we're not using rswag.
Yeah.
But yeah, I haven't. I should probably revamp, check to see if there's a newer version of I'm using JSON schema. So
yeah, the only reason I used the JSON schemer is just because it was in place in the app. I've never heard reference to it over the normal JSON schema one. Yeah.
great. I don't think I had a follow-up question, but for now.
Okay.
Find you later.
Yeah, sounds good.
There is a question from the chat, maybe even several. So the first one is how JSON scheme uses OpenAPI.
So the question is, how does JSON schema use OpenAPI? And my understanding is that it doesn't, but that the specs are very, very similar. So there are some differences between the two. There are some things that are supported in one and not supported in the other. I don't think the current state of either is that it's simply one is a superset of the other. It's they have 95% the same core and then a couple little different things here and there.
So there is a continuation, maybe partially covered it, but does rswag use OpenAPI as well?
Yes. So rswag, does rswag use OpenAPI? So rswag is basically like the Ruby, probably pull it up pretty quick. Yeah, so Swagger and OpenAPI are basically like the same thing nowadays. I think Swagger was the original name and OpenAPI is like the more current canonical name as they've moved more into like truly defining a spec over being just like a tool. But yeah, so rswag is, as far as I know, kind of the canonical Ruby tool for OpenAPI or Swagger. Any other questions? All right. I will take this thing off again. Oh, do you have something? Oh, okay.
Okay. We're going to take a 10-15 minute break. Yeah, we'll be back in a bit. Do you want me to speak? Okay, yeah. Oh, I said, okay. Yeah. Hi, remote attendees. We are gonna pick back up with our second speaker, Patrick McSweeny. I hope I said your name right. Great. All right, give it up.
I don't see it in there. This one? Okay. Okay, cool. So hi, everyone. My name is Patrick. I live in Ann Arbor, Michigan. So I'm not quite as far away as Raleigh, North Carolina, but I did still have to travel a ways to get here. This is actually the second time I've spoken at Chicago Ruby. About 7 years ago or so, I did a presentation on Ruby and Rails performance, so you may or may not remember that. But tonight I'm going to be talking about Hotwire, your UX. So I'm going to be talking about a little bit about Hotwire and how it can be used to enhance the user experience of your web application. So I'm going to spend a little bit of time explaining the underlying technologies of Hotwire and also how it can benefit your. Oh. Okay, okay, yeah, no big deal. Okay, so I'm picking back up. I'm going to explain how Hotwire can benefit your users. So you've probably heard about Hotwire being good because it allows you to develop features, more easily and more quickly than some other approaches. And that's well and good, but more importantly, I think Hotwire can also benefit your users, and I think that's really the big reason it should be used in your web application. So about me, I started browsing the web in the late 1990s. Might give you an idea of how old I am. I started developing for the web around 2007. So that's when I did my first, Hello World web page. And the reason I bring this up is because I grew up with the web both, using server-side rendering both as a user and as a developer. So that's really kind of shaped my understanding of how the web operates. And some younger people who have grown up with client-side rendering, might have a bit of a different perspective. So I was a history major in college, so I always like to work a history angle into my presentations whenever possible. So from the mid 90s up until about 15 years ago or so, pretty much all websites were server-side rendered with a few exceptions here and there. But pretty much every website you would encounter in that era would be, rendered on the HTML would be rendered on the server, and then the browser would download that and then render it. And then in the early part of the previous decade, client-side rendering started taking over, frameworks like Ember or Angular and so forth. And it really kind of picked up steam from there. And I think there was a couple of reasons for that. I think a big one was basically an out with the old, in with the new mentality. People thought, oh, server-side rendering, that's old, client-side rendering is new. We should embrace it. And that's what a lot of people did. Also, a lot of developer boot camps or developer schools in this time period. From what I've heard, a lot of them primarily or only taught client-side rendering to their students. So if you attended one of those, you might not have ever learned how to do server-side rendering unless you actually took the time to learn it on your own. So I'm going to compare and contrast server-side rendering versus client-side rendering and some of the positives and negatives of each. So starting off with server-side rendering, it's relatively easy to develop. In most cases, you can get something developed easier and faster using server-side rendering than you would with client-side rendering. There's if you're using server-side rendering, you're probably not using a lot of JavaScript. So this means less resource consumption for the client because you don't have a lot of JavaScript to download and run. It's easy to make accessible. So with server-side rendering, if you're just using regular links and forms for your application to build interactions, there's not a whole lot of work that needs to be done to ensure a basic level of accessibility. And accessibility is something I'm really passionate about. I think you should want all of your users to have a good experience when they're using your application. You don't want it to only be limited to the people who are lucky enough to have good eyesight. Also, with server-side rendering, it's easier to make it work with the browser API. So things like the back button, or hitting enter to or return to submit a form. Those work in most cases just by default with server-side rendering. Of course, there are drawbacks as well. So the web was originally invented to display documents, and then people started using it to build applications. But the full page refresh, it makes it feel like you're using a website and not an application, and it can be jarring for the user. And also, if you have complex user interface logic, you can run into some limitations with the more traditional server-side rendering approaches. And I think that's part of the reason that client-side rendering started to take over, is because people ran into those limitations. So obviously, client-side rendering, it makes it easier, or enables you to write a more complex and interactive user interface by default. And also, it feels more like you're using an application, not a website, because with client-side rendering, it's a lot easier to only update the parts of the page that have changed. So it ends up being a smoother user experience. But there are some downsides as well. It's resource intensive for the client. There's more JavaScript to download, compile, and run. Also, the just-in-time compiler, that's the technology that allows browsers to run JavaScript at high speeds. And basically, it analyzes the code as it's being run to try to find optimizations. But that does come at a cost, because the compiler itself does consume resources in order to achieve those high speeds. So JavaScript can be fast, but it's not really efficient. And as a result, JavaScript heavy websites, they don't run as well on mobile devices or slower computers. And I think there tends to be some disconnect between developers and users, because us developers, we like to have fast computers because it makes us more productive, and most of us are computer nerds anyways. But your average user, they might be using a 10-year-old Windows computer that's loaded with viruses and whatever else. So the experience that they have using your website might be quite different than the one you have when you're using it on your computer. Also, one weird UX anti-pattern that I've noticed on a lot of client-side rendered sites is I'll load a web page, and the initial state is to say no content found, like no notifications found or whatever, and then half a second later, that will be replaced by the content once it's actually been loaded from the server. And I know that it's probably possible to write more code in order to not have that weird experience of telling the user that the website didn't find any content when it just hasn't loaded yet. But in my mind, this is an example of how client-side rendering has drawbacks from the user experience standpoint. Also, with client-side rendering, it makes it easier to kind of develop applications in a way that do not really match web standards. So you don't necessarily need to use like links or forms in order to create interactions. And you can, use the area attributes in order to make things accessible. But in most cases, compared to server-side rendering, it is more difficult to make client-side rendered web applications accessible. And it's also, in a lot of cases, more difficult to make it work with the browser API. Like in a lot of client-side rendered sites, hitting the back button ends up wiping out a lot more progress than you might have anticipated. And it is possible to make this work more properly, but it's something that you have to be vigilant about, and it requires more work. And also with client-side rendering, I think this was kind of alluded to in the previous presentation. You sometimes end up with redundant logic on the front and back ends. And this is more of a developer problem than a user problem, but it can turn into a user problem if you don't make sure to keep everything in sync between the front and back ends. So it's just another thing you have to worry about. Also, in my opinion, when you have more complexity, that just means more things that could break. And with client-side rendering, you're basically introducing more complexity. And also, unstable connections can do some weird things with client-side rendered sites. So, you know, like me personally, I've had experiences trying to use a website on like a McDonald's Wi-Fi or a connection that's not very good. And some of the requests succeed and some of the requests don't succeed. And then, you know, weird stuff happens. And I think it's sometimes better to just fail altogether or succeed altogether, because when you succeed partway, you know, weird stuff happens that you don't necessarily want to have happen. So as you can probably guess, I'm not a fan of client-side rendering for the most part. But there's no reason for despair. You know, there's been a lot of advancements in web technology in the last 15 years since client-side rendering started taking over. So, and these advancements make it easier to develop rich and interactive user interfaces, you know, using server-side rendering. So some of these technologies include fetch requests, and this makes it a lot easier to grab HTML or other content from the server, from the client side. The history API lets you literally rewrite the browser history. So that's really cool. Like that's, you know, been a frustration for web development for a long time. And web components, before I started learning about Hotwire, I honestly did not know a whole lot about web components, but since I did start learning about it, I've realized that this is actually pretty cool technology, because what it allows you to do is allows you to actually isolate different parts of the web page and have the JavaScript for the different individual components, you know, not interfere with each other. And also, WebSockets provide a continuous connection between the client and server with events. And CSS view transitions allow you to make you know, full page reloads that don't look like full page reloads to the user. It creates the illusion that you know, they're using an application. So now is the part of the presentation where I'm actually going to start talking about Hotwire specifically, and I'm going to start off by just giving a brief overview of Turbo Drive and what it does. So if you install Turbo Drive in your Rails application, when you click a link or submit a form, instead of doing a full page reload, it'll make a fetch request to the server, and then it will only update the contents of the body tag. So what this means is that the head tag is not getting reloaded, and the head tag is usually where you're loading all or most of your CSS and JavaScript. So not only does the CSS and JavaScript not need to be reloaded, it also does not need to be recompiled. So that speeds things up a lot and saves resources for the user. So basically, if you install a Turbo Drive, it greatly speeds up, you know, regular link clicks and form submissions. So this gives you kind of the application-like feel with, you know, basically doing very little on your end as a developer. And what I should add to this is the Turbo Drive also uses the history API. So if you click a link, it will make the fetch request, but then it'll also add the request to the browser history, so you can use the back button, and also it'll be in your history, assuming that's something you actually want. Also, an optional part of Turbo Drive is what's called morphing. I haven't really used this personally, but what morphing does is it only refreshes the parts of a web page that have actually changed. So this gets even more granular, but this is not enabled by default. This is something you would actually need to enable if you actually want to use it. So I'm going to move on to talk about Turbo frames and Turbo streams, which is, you know, from a developer standpoint, is probably the, you know, more exciting part of Hotwire. And underneath the surface, they're really just, you know, using web components and that functionality. So What are web components? It's basically a custom HTML element that's registered with a JavaScript API in the browser. And this is actually native browser functionality. You don't need any external dependencies to do this. And web components, they can, it's optional, but they usually contain their own JavaScript and HTML templates within the component. And the JavaScript functionality is completely encapsulated by the browser. So this makes it, if you have a lot of different JavaScript running in different places, it can start to interfere with each other. But web components makes it easier to encapsulate. So you can have different parts of the web page running their own JavaScript a lot easier. And also web components, by default, they have JavaScript callbacks, which get called whenever whenever a web component is added or removed to the page. And Hotwire taps into this functionality in order to interact with the page. And also web components are designed to be reusable. So once you've registered them, you can use them throughout your web application and also multiple times on the same page. So turbo frames, you might be familiar with frames or iframes. I don't think anyone uses actual frames anymore, but basically what frames and iframes do is they allow you to embed an external web page inside of another web page. And it used to be more common in the older days of the web, but it's fallen out of favor somewhat. But turbo frames, from a user standpoint, they kind of function in a similar way to frames, HTML frames. But from a functionality standpoint, they work completely differently. They have absolutely nothing to do with frames. So I guess I kind of have mixed feelings about the name turbo frames, because it helps you understand what they do from a user perspective, but it's actually highly misleading for how they actually work. And they don't use frames. They basically just use a web component, and then the JavaScript inside of that web component grabs HTML that's being rendered on the server, and then uses that to update the part of the web page that the web component is occupying. So this is really useful for if you want to do something like displaying search results. You can have just the part of the page that displays the search results update when someone submits the form, instead of having to do a full page refresh every time submits a search form. And it's also useful for things like inline editing. If you want your users to be able to edit content directly on a page without having to navigate away, or have some sort of modal pop-up or something, it's useful for that. And you can actually make all this work without writing any JavaScript on your end. So it's pretty cool from that end. So turbo frames are great if you just need to update a certain area of the page, but what they cannot do is interact with existing elements on a web page. So that's where turbo streams come in. And turbo streams is basically just a web component that accepts a targeted action as parameters. So is there, well, I think I'll just point. So as you can see, I got this example from the Hotwired documentation website. So this has the append action and the messages target. So if this web component gets added, or this turbo stream web component gets added to a web page, it'll search for the element with the ID of messages, and then it'll append the content of the template to that existing element. And there are also web turbo streams, for other common operations like, updating the content of an element, or removing an element. So it's really cool because you can, without using any JavaScript whatsoever, you can manipulate and update, existing elements on a page. And you can add them via JavaScript, although you probably wouldn't need to in most cases. And also you can use them as server responses. So if you've used RJS or UJS, those have actually been replaced in Rails 8 officially by turbo streams. And that's so you can set up your controller actions to return turbo streams instead of doing a redirect or loading HTML. So for instance, if you have a delete button for an item on a web page, when the user clicks the delete button, it makes a request to the server, and then you can have the server respond with a turbo stream that would remove the element from the page on the user's end. So that was something you used to be able to do with UJS, but turbo streams are better because you don't need to actually write any JavaScript, and it's also more secure because you don't need to worry about the JavaScript from the server being tampered with before it reaches the user's browser. And what's really cool is you can actually connect to WebSockets with turbo streams simply by using the turbo stream from helper in your Rails view. So WebSockets, basically it's a continuous two-way connection between the client and the server, and it comes with bindable events. And what's really cool is you can actually broadcast content from the server to the client. So if you want to update the user screen based on something happening on the server, you can do that rather than having to make requests from the client every on a certain interval or something like that. And also, it allows connection issues to be more intelligently dealt with. So if the user's connection drops and then they reconnect, you can use the bindable events to deal with those connection issues in a more intelligent manner, and let the user know what's going on so they're not confused, and you don't run into weird state issues by having a non-stable connection. And this is not really specific to Hotwire, but cool development in CSS recently is something called view transitions. So this is some sample CSS. If you add this to your CSS file, whenever a page refresh happens, this will animate the page refresh and make it a lot smoother. So it's not completely wiping everything out on the screen in between. So final notes. You can use Hotwire outside of Rails. It was developed, I think, mostly by the Rails team, but if you want to use something else on the back end, you do have that option. And you can still use JavaScript in JavaScript libraries. I didn't really cover it tonight, but Stimulus is also designed to be able, create interactions with very little JavaScript. But JavaScript libraries like React are also available. If you want to have that functionality in certain areas of your website. So it's not an either or between using Hotwire and using other JavaScript libraries. So in conclusion, this is my opinion, but I think Hotwire enables a rich user interface with minimal JS, and I think less JS for the most part means a smoother experience for the user. If there's any JavaScript fans here, please, hopefully I didn't offend you, but that's my opinion. So if you're interested in learning more, I highly encourage you to really read the MDN docs on documentation on web components and WebSockets. The Learn Hotwire course by Chris Oliver, he's the guy behind Go Rails. That's really useful and actually how I learned most of what I put into this presentation tonight. Also, final note, I am looking for a job, so if anyone is interested in hiring me, please let me know. But that wraps it up. Any questions? All right. Well, thanks, everyone. Oh, darn.
The recording is done. Yeah. That's all we have, folks. But if there's more food, I don't know where the cafe was, but that way and that way or something like that. Please grab food. But yeah, that's pretty much it. Thank you for coming. Can I let you drive your machine?
Or server or Hotwire. Can you move?
So that's it. I like. Okay, no, that sounded like I thought it was fun.